हेलो दोस्तों, वेलकम टू द साइनिंग ब्रेन। आज हम एनसीईआरटी का क्लास 7 चैप्टर नंबर 8 पढ़ने जा रहे हैं। चैप्टर का नाम है विंड्स, स्टॉर्म्स एंड साइक्लोन्स। नाउ लेट्स स्टार्ट। Odisha was hit by a cyclone with wind speed of 200 km per hour on 18 October 1999. The cyclone smashed 45,000 houses, making 7 lakhs people homeless. On 29 October, the same year, a second cyclone with a speed of 260 km per hour hits Odisha again. It was accompanied by water waves about 9 meter high. Thousands of people lost their lives. Property worth a crore of rupees was destroyed. The cyclones affected agriculture, transport, communication, and electricity supply. This is the figure 8.1 image taken by a satellite of a cyclone approaching the coast of Odisha. But what are cyclones? How are they formed? Why are they so destructive? In this chapter, we shall seek answers to some of these questions. We begin with some activities involving air. These activities will clarify some basic features concerning a cyclone before we begin. Remember that the moving air is called the wind. 8.1 Air pressure exert. Activity 8.1. Whenever an activity involving heating, be very careful. It is advised that such activities are performed in the presence of an elderly person from your family, or carry out this activity in the presence of your teacher. You need to boil water in the following activity. Take a tin can with a lid, fill it approximately half with water, heat the can on a candle flame till the water boils. Let the water boils for a few minutes, but blow out the candle immediately. Put the lid tightly on the can. Be careful in handling the hot can. Put the can carefully in a shallow metallic vessel or a wash basin. Pour fresh water over the can. What happened to the shape of the can? Here figure 8.2, can with hot water being cooled. Can you guess why the shape of the can get distorted? If you cannot get a tin can, take a soft plastic bottle, fill it with hot water, empty the bottle and immediately cap it tightly. Place the bottle under running water. Recall now some of your experiences when you fly a kite. Does the wind coming from your back helps? If you are in a boat, is it easier to row if it is wind is coming from behind you? Do you find it difficult to ride a bicycle against the direction of wind? You know that we have to fill air into the bicycle tube or to keep it tight. Also, you know that a bicycle tube overfilled with air may burst. What is the air doing inside the tube? Discuss with your friends how the air in the cycle keeps tube in shape. All these experiences show that the air exert pressure. It is due to this pressure that the leaves of tree, banner or flags flutter when the wind is blowing. Where you can list some more experiences which show that the air has pressure. Let us now try to explain why the can or the bottle get distorted. As water is poured over the can, some steam in the can condenses into water, reducing the amount of air inside. The pressure of the air inside the can decreases than the pressure exerted by the air from outside the can. As a result, the can get compressed. This activity again confirms that air exerts pressure. 8.2 High speed winds are accompanied by reduced air pressure. Activity 8.2, figure 8.3, blowing into the bottle. Crumple a small piece of paper into a ball of size smaller than the mouth of an empty bottle. Hold the empty bottle on its side and place the paper ball just inside its mouth. Now try to blow on the ball to force it into the bottle. Try the activity with bottle of different sizes. Challenge your friends if they can force the paper ball in by blowing into the bottle. Paheli and Bozo are thinking about the following question: why is it difficult to force the paper ball into the bottle? Activity 8.3: Blow the balloons. Take two balloons of approximately equal size, put a little water into the balloons, blow up both the balloons and tie each one to a string. Hang the balloon 8 to 10 cm apart on a cycle spoke or a stick. Blow in the space between the balloon. What did you expect? What happens? Try different ways of blowing on the balloons to see what happens. Activity 8.4: Can you blow and lift? Hold a strip of paper 20 cm long and 3 cm wide between your thumb and forefinger as shown in figure 8.5. Now blow over the paper. Paheli thinks that the strip will be lifted up. Bojo thinks the strips will bend down. This is the figure 8.5, blowing over a strip of paper. What do you think will happen to the papers? Let us try to understand the observation in activity 8.2, 8.3 and 8.4, where the observations along the lines you thought. Do you get the feelings that the increased wind speed is accompanied by a reduced air pressure? When we blow into the mouth of the bottle, the air near the mouth has higher speed. This decreases the pressure there. The air pressure inside the bottle is higher than near the mouth. The air inside the bottle pushes the ball out. In activity 8.3, you saw that when you blow between the balloons, they move towards each other. How could this happen? This could happen if the pressure of air between the balloons were somehow reduced. The pressure outside the balloon would then push them towards each other. In activity 8.4, you saw that when you blow over the paper strip, it will bend to upward. Again, this could happen if blowing over the paper reduces the air pressure above the strip. We see that the increased wind speed is indeed accompanied by a reduced air pressure. Can you imagine that would happen? What would happen if high speed winds blow over the roof of buildings? If the roof were weak, they could be lifted and blown away. If you have any such experience, share it with your friend. Let us try to understand how winds are produced, how they bring rain, and how they can destructive sometimes. You already know that when air moves, it is called winds. Air moves from the region where the air pressure is high to a region where the pressure is low. The greater the difference is in pressure, the faster the air moves. But how the pressure difference creates in nature? Is the difference in temperature involved? The following activities will help you to understand this. Here, figure 8 shows the shape of the balloon in the hot and cold water. First figure shows balloon tied over the neck of the boiling tube. Second figure, balloon tube immersed in hot water. Third figure shows boiled tube immersed in ice cold water. Eight point three, air expand on heating. Activity 8.5, take a boiling tube, stretch a balloon tightly over the neck of the tube. You can use a tape to make it tight. Pour some hot water in the beaker. Insert the boiling tube with the balloon in the hot water. Observe for 2 to 3 minutes for any change in the shape of the balloon. Take the tube out. Let it cool down to the room temperature. Take some ice cold water in another beaker and place the tube with the balloons in cold water for 2 to 3 minutes. Observe the change in the shape of balloon. Think and try to answer. What makes the balloon inflated when the boiling tube is placed in hot water? Why is the same balloon deflated when the tube is kept in the cold water? Can you infer from the first observation that air expands on heating? Can you now state what happened to the air in the boiling tube when it's cooled down? The next activity is very interesting. This will make you understand more about the hot air. Activity 8.6. Take two paper bag or empty paper cup of the same size. Hang the two bag in the inverted position on the two end of the metal or a wooden stick. Tie a piece of thread in the middle of the stick. Hold the stick by the thread. Figure 8.7 as in a balance. Here figure 8.7 shows hot air rises up. Put a burning candle, blow one of the bags as shown in figure. Observe what happened. Why is the balance of the bag disturbed? Thus, this activity indicates that warm air rises up. As the warm air rises up, it pushes the bag above the candle. Thus, the disturbance of the balance suggests that the warm air is lighter than the cold air. Can you now explain why smoke always rises up? Also, it is important to remember that on heating, the air expands and occupies more space. When the same thing occupies more space, it becomes lighter. The warm air is therefore lighter than the cold air. That is the reason that the smoke goes up. In nature, there are several situations where warm air rises at a place. The air pressure at that place is lowered. The cold air from the surrounding areas rushes in to fill its place. This sets up convection in air as you learned in chapter 4. 8.4. Wind currents are generated due to the uneven heating on the earth. These situations are: A. Uneven heating between the equator and the poles. You might have learned in geography that regions close to the equator get maximum heat from the sun. The air in this region gets warm. The warm air rises and the cooler air from the region in the 0 to 30 degree latitude belt on either side of the equator moves in. These winds blow from the north and south towards the equator. At the poles, the air is colder than that at latitude about 60 degrees. The warm air at this latitude rises up and the cold wind from the polar region rushes in to take its place. In this way, wind circulation is set up from the poles to the warmer latitude as shown in figure 8.8. Figure 8.8 shows the wind flow pattern because of uneven heating on the earth. I wonder why the winds shown in the figure are not in the exact north-south direction. The winds would have flown in the north-south direction from north to south or from south to north. A change in the direction is, however, caused by the rotation of the earth. B. Uneven heating of land and water. You have read about the sea breeze and the land breeze in chapter 4. In summer, near the equator, the land warms up faster and the most of time the temperature of the land is higher than that of the water in the ocean. The air over the land gets heated and rises. This causes the winds to flow from the oceans towards the land. These are monsoon winds. The word monsoon is derived from the Arabic word mausam, which means season. In winter, the direction of the wind flow gets reversed. It flows from the land to the ocean. Bozo, I want to know what these winds do for us. These winds from the ocean carry water and bring rain. It is a part of the water cycle. The monsoon winds carry water and its rains Cloud bring rain and give us happiness. Farmer in our country depends mainly on rains for their harvest. There are many folk songs associated with clouds and rains. Sing and enjoy with your friends. If you know such a song, here is one for you. Here one song is given in the box. You can, if you want to read, you can. Figure 8.9, uneven heating of land, especially the Rajasthan desert, generate monsoon winds from southwest direction in summer. These winds carry lots of water from the Indian Ocean. However, it is not always a happy ending. Rains often creates problems. Can you list some of the problems? You can discuss the cause and solution of the problems with your teachers and parents. In nature itself, there are certain situations that can sometimes create disaster and pose threat to humans, animals, and plants' life. Let's study two such situations: thunderstorm and cyclones. Here figure 8.10, uneven heating of land and water in winter generates winds from northwest colder land. These colder winds carry little water, hence bring a small amount of rain in winter. Now 8.5, thunderstorm and cyclones. Thunderstorm develop in hot humid tropical area like India very frequently. The rising temperature produces a strong upward rising winds. These winds carry water droplets upward where they freeze and fall down again. The swift movement of the falling water droplets along with the rising air creates lightning and sound. It is this event that when we call a thunderstorm. You will read about lightning in higher classes. If a storm is accompanied by lightning, we must take the following precautions. Do not take shelter under an isolated tree. If you are in a forest, take shelter under a small tree. Do not lie on the ground. Do not take shelter under an umbrella with a metallic end. Do not sit near a window, open garage, storage sheds. Metal sheds are not safe place to take shelter. A car or a bus is a safe place to take shelter. If you are in the water, get out and go inside a building. How a thunderstorm become a cyclone? You know that water requires heat when it changes from liquid to vapor state. Does the water give back heat when the vapor condenses into liquid? Can you really recall any experiences to support this? Structure of a cyclone. The center of a cyclone is a calm area. It is called the eye of a storm. A large cyclone is a violently rotating mass of air in the atmosphere 10 to 15 km high. The diameter of eye varies from 10 to 30 km, figure 8.11. It is a region free of cloud and has light winds. Around this calm and clear eye, there is a cloud region of about 150 km in size. In this region, there are high speed wind 150 to 250 km per hour and thick clouds with heavy rains. Away from this region, the wind's speed gradually decreases. The formation of cyclone is very complex process. A model is shown in figure 8.11. Before cloud formation, water take up heat from the atmosphere to change into vapor. When water vapor changes back to the liquid form and as rain drop, this heat is released to the atmosphere. The heat released to the atmosphere warms the air around. The air tends to rise and causes a drop in pressure. More air rushes in to the center of a storm. This cycle is repeated. The chain of events ends with the formation of very low pressure system with a very high speed winds revolving around it. It is this weather condition that we call a cyclone. Factors like wind speed, wind direction, temperature, and humidity contribute to the development of cyclones. Here figure 8.1 formation of cyclone. 8.6 Destruction caused by cyclones. Cyclones can be very destructive. Strong winds push water towards the shore even if the storm is hundreds of kilometers away. These are the first indication of the approaching cyclone. The water waves produced by the wind are so powerful that a person cannot overcome them. The low pressure in the eye lifts water cycle in the center. The rising water may be as high as 3 to 12 meter. Here figure 8.12 the image of the eye of a cyclone, and figure 8.13 rising water caused by a cyclone. Figure 8.13 it appears like a water wall moving towards the shore. As a result, the sea water enters the low lying coastal areas causing severe loss of light and property. It also reduces the fertility of the soil. Continuous heavy rainfall may further worsen the flood situation. High speed winds accompanying a cyclones can damage houses, telephones, and other communication systems, trees, etc., causing tremendous loss of the life and property. A cyclone is known as different names in different parts of the world. It is called a hurricane in the American continent. In Philippines and Japan, it is called a typhoon. Figure 8.11 8.14 regions near the equator where cyclones form. Cyclones are worldwide phenomena. The diameter of a tornado can be as small as meter and as large as kilometer or even wider. The funnel of a tornado sucks dust, debris and everything near it at the base due to low pressure and throw them out near the top. Here are a few accounts of survival of tornadoes from Discovery Channel Young's Discovery series. I saw the cloud coming and tried to take shelter inside. But as soon as I reached from the doorknob, the house took off into the sky. I was not hurt at all. After the storm, we had to clean the debris from the wheat field. We picked up splintered board and tree branches as well as dead chicken with their feathers blown off and rabbits looked like they had been skinned. A tornado shelter is a room situated deep inside on the underground having no windows, or otherwise it is better to shut windows and take shelter under a table workbench where debris cannot reach. One has to bow down or knees, protecting head and neck using arms. Figure 8.15 Protecting from a tornado. Tornado. In our country, they are not very frequent. A tornado is a dark funnel shaped cloud that reaches from the sky to the ground. Most of the tornado are weak. A violent tornado can travel at a speed of about 300 km per hour. Tornado make form within cyclones. The whole coastline of India is vulnerable to the cyclones, particularly the east coast. The west coast of India is less vulnerable to cyclonic storms both in terms of intensity and frequency of the cyclones. 8.7 Effective safety measures. A cyclone forecast and water warning services. Rapid communication of warning to the government agencies, the ports, fishermen, ships, and to the general public. Figure 8.16 Image of a tornado. National Severe Storm Laboratory NSSL. We have learned that all storms are low pressure systems. Wind speeds plays an important role in the formation of storms. It is therefore important to measure the wind speed. The instrument that measures the wind speed is called anemometer. Figure 8.17, an anemometer for measuring the speed of wind. Construction of a cyclone shelter in the cyclone prone area and administrative arrangement for moving people fast to safer place. Action on the part of the people. We should not ignore the warning issued by the meteorological department through TV, radio, or newspaper. We should make necessary arrangements to shift the essential household goods, domestic animals, and vehicles etc. to the safer place. Avoid driving on roads through standing water, as flood may have damaged the road, and keep ready the phone numbers of all emergency services like police, fire brigade, and medical centers. Some other precautions if you are staying in a cyclone's hit area. Do not drink water that could be contaminated. Always store drinking water for emergencies. Do not touch wet switches and fallen power lines. Do not go out just for sake of fun. Do not pressurize the rescues for by making undue demands. Cooperate and help with your neighbors and friends. 8.8 Advanced technology has helped. This day, we are better protected. In the early part of the last century, coastal residents may have had less than a day to prepare or evacuate their homes from an overcoming cyclones. The world today is very different. Thanks to satellite and radars, a cyclones alert or cyclones watch is issued 48 hours in advance of any expected storm, and and a cyclone warning is issued 24 hours in advance. The message is broadcast every hour or half hour when a cyclone is near the coast. Several national and international organizations cooperate to monitor the cyclones related disasters. Now keyword: anemometer, low pressure, tornado, cyclones, monsoon wind, typhoon, hurricane, pressure, wind flow pattern, lightning, thunderstorm. This is the end of this chapter. तो नेक्स्ट क्लास में हम चैप्टर नंबर 9 के बारे में पढ़ेंगे. तब तक के लिए थैंक यू, धन्यवाद.